that this is about 300 ohms or so of resistance. And we can keep going down. Okay, well, it's probably 325 ohms of resistance. Hey folks, how's it going? My name is Luke. Welcome to the channel. And today we're going to be going over all of the different test functions on your Gardner Bender GDT 3190. It is a manual ranging digital multimeter. So if you're a beginner, you're new to electrical testing, you want to improve your electrical testing, you're not familiar with manual ranging meters, or if you're simply looking for a product review before or after you purchase this meter, this video is for you. I want to go ahead and say that I will be giving this meter a little bit of a hard time. I've had Gardner Bender on the channel before, and it was pretty disappointing. I don't expect this meter to be any different. That being said, grab a snack, have a seat, sit down, enjoy the video. I hope you get something out of this. Let's go ahead and get into it. So before I walk you through the wheel here and all the different test settings, I have had Gardner Bender. This is their analog meter. I've had it on the channel before. I'll try to link it in the video. Should be up here for you. And man, this thing, I found it on like a recommended list, like top multimeters of like 2024 or something like that. And it's the only analog meter I've had, and it's just not great. And it's kind of a letdown because I know analog meters can be really great, and it was expensive too. If you're having trouble trying to get to the battery in this thing, no worries. A little flathead like this and gingerly ply back on this outer casing right here, and this whole thing will peel off. And then there's two Phillips screws back here to get to that 9 volt. And then a red flag for me whenever I'm looking at meters and their design or like their packaging or just getting a feel for the meter is when I see the meter port leads like deformed like this, that's never a good sign. It tells me that these leads are really cheap and that they're gonna fail pretty quickly. I mean, if you're just using this every once in a little, like very light use, you keep it in the toolbox or whatever out in the garage, and you're going to use it like every couple of years to check something. I mean, I think that's probably what this is built for, but there's not a whole lot of functionality. There's no testing for capacitance. You can't measure current of any kind. Really, all we have available to us is going to be these resistive measurements, these battery tests, and before you even write down in the comments, this 12 volt battery test is like a marketing gimmick. They put this on meters to give you the idea that you can test your car battery with your multimeter. There are ways of testing car batteries and doing different checks. This is not going to tell you if you have a good or a bad car battery. You need a special setup just for that. For the 9 volt and the 1.5, these are fine. This will do just great. Then we have our volts DC. And then something that I haven't seen before is for our voltage AC section, we're only rated up to 500 volts AC. So I thought that was really interesting. And then we have our hold button for holding the values. That kicks in. It's not going to work. You're not going to be able to see. Let me get you set up here. Let's check. Ooh, I do like that display though. That's not bad. Some of the liquid crystal displays I've come across recently are not great, and that one looks pretty crisp. It's displaying a 1 right now, which essentially on any other type of meter, it would normally say OL, which stands for either out of limits or open loop, which basically means it's in an open circuit configuration. And then 2, I don't know about you all. I don't know if you just bought this or what, but when I opened it, this thing smelled like chemicals bad. And that I just never liked. I'm not a big fan of that. Make sure those leads are fully seated in there. And then let's see. Okay, so now we're showing, it doesn't even have a continuity setting, which is insane. Like even the cheapest meters have a continuity setting. So to me, I give this meter a hard time. If this meter was like $12, $12 to $14 USD, I wouldn't be giving it a hard time. I always try to take the price into context when making judgments about a meter. For learning manual ranging multimeters, there's a few things that I want us to think about. We've kind of already done a tour of the wheel, and we're going to be looking at our resistive values here. And I know there's a lot of numbers on here and it can be kind of confusing, but this omega symbol here is telling us this section is what is for measuring resistance, okay? I want you to think of these numbers as up to. This first setting here can measure up to 200 ohms. If it's anything bigger than that, you'll have to go to the next setting. This one can measure up to 2000 ohms. If you have, let's say we have 100 ohms resistor that we want to take a measurement of, that's how you use that hold function. It holds that value for you. Okay, so we have a 99 ohm resistor and we're on the 200 ohm setting. So anything up to 200 ohms, it can read. Anything above that will get a 1. Now, let's say you're on the 2000 ohm setting. Can you measure something that's less than 200 ohms? And you can. You're just not going to get the clarity or the detail that you were able to before, the accuracy. See how it's saying 99 or 100 as opposed to that, 99.1 that we were getting earlier? Is I like to start at the biggest setting and work my way down into a clearer and clearer picture until I get the most resolution out of it. Like a microscope, when we're using one, we start with the lenses way back here and everything's blurry. We don't really have an idea of what's going to, we know something's going on down here, but we don't know exactly what. And then as we bring a microscope into focus, everything comes into clarity. Same kind of idea when we're using a manually ranging multimeter. We want to start with the highest number till we can get an idea of what we're looking at. And then we can start to dial it in and get a finer and finer measurement until we can't go any further. And we get that 1 letting us know it's out of limits. So if we're on the 2000 setting, that lets us know, okay, this is 984 ohms of resistance. We're going to do a couple more examples with reading this. Let's take this resistor. We're going to start with the biggest value. Okay, we're on the 2000K setting. What the meter should be saying, and this is another hard thing, is it should say 2 mega ohms, 2 capital M. The 2000K can be really confusing, but we're in the 2000K setting and we're seeing a 098. The way that we would read that for this setting is this is 98,000 ohms. Is 98,000 smaller than 200,000? Yes, it is. So we know that if we want to get more resolution, more detail of this reading, we can go to the next setting down, and now we have a tenths place, and our numbers changed because it's more accurate. We now know it's not just 98,000, it's really 97,700 ohms of resistance. If we go to the next one down, it's going to get that 1 because 97,000 is greater than 20,000. So let's bring that back up to the top. Let's do another example. This is going to be the same way with your volts DC and your volts AC readings. We're on the 2 million setting, okay? The 2000K setting, and we just see a 1. So what would that tell us? Well, we can imagine an imaginary 1 here. So let's carry the decimal. Okay, I think that's 1,000. I think it's trying to say there's about 1,000 ohms there. But let's dial it in and see what we start to get. Looking more like 1,000. Okay, looking closer to not 1,000 but 980. Let's go to the 2000 setting. Okay, 980 ohms of resistance. We'll do one more just to really drive it home. Okay, I have a 0, 0, 0, but I don't have a 1. So the meter is trying to tell me, hey, I can read some kind of resistance, but whatever the number is, it's too small for me to give you a value. So let's go down to the 200K setting. Okay, so there's a good chance that this is about 300 ohms or so of resistance, and we can keep going down. Okay, well, it's probably 325 ohms of resistance. So that's the way that you would kind of walk down the settings to fine tune your measurement to get a really good exact number. Let's go over the battery test. The battery tests are going to be should be very straightforward. It starts with a 12 volt. So let's go ahead and just bring up a 12 volt battery. So it's measuring 13.34. These battery tests, the way that it works is the meter puts a little tiny load on the battery and kind of stresses it and then gives you the voltage as the battery is stressed. And that's the way that we're checking the voltage. I can do that for 9 volts. I have no clue the state of this 9 volt battery. Okay, this 9 volt battery is not looking great because under stress test, it's showing 8.3. And when we're dealing with battery voltages, a few tenths of a volt can be a big deal. That's like about a whole volt lower. Normally, a 9 volt battery is about 9.5 volts when it's nice and healthy. So that's telling me there's a good chance this battery is about dead or getting close. And then we have our 1.5 volt battery test. And just red to positive, black to negative. This one's coming in above 1.5 volts, so that's good. And then we can go into voltage. Now, voltage is going to be the same kind of idea when we don't know what kind of voltage. And if you're not sure, this is DC voltage range right here. We want to do the same thing. We want to think up to, so this can measure up to 20 volts DC, up to 200, and so forth. And then we always want to start at the biggest number. So we can always start at the 600 volts DC. We can take a measurement of an unknown voltage source, and then we can start to work our dial down and bring things down into clarity for us. Okay, so we're seeing a 13. 13 what? For a battery like this, the difference between like 13.3 and 13 flat, that's a big difference. So we can walk it down. Now we're seeing 13.2, 0.3. Walk it down one more. Okay, 13.27 is what we're looking at for the charge, for the voltage charge of this battery. And some of you might be wondering a couple things. What is the lowercase m for? The lowercase m is for milli. So if we have 2000 millivolts, that's for up to 2 volts. And then 200 millivolts. So those are very, very small amount of voltages. And then what's the difference between using the volts DC and the 9 volt battery? And we can look at the internal resistance of what the meter is putting out. So when it's in the normal up to 20 volts DC setting, we're going to see a lot of resistance. We've got 10 mega ohms. So we just learned how to read resistive measurements. I know there's not an M on here, but M is the next above K. So that's 10 million ohms of resistance that it's reading into internal to the meter. If I put it on the battery mode, now we can see it drop down to 680 ohms of resistance. So if we look at Ohm's law, as resistance goes down, current draw comes up, and that's how it stress tests the batteries. And then one last note, when we're doing DC voltage measurements, we want to have the red to red, the black to black. If not, we'll get a negative sign. You'll see there. And that just means that your polarity is flipped. And then we'll do, lastly, volts AC. Now, unlike volts DC, with volts AC, the polarity of your leads, that means the red to red, the black to black, it doesn't matter. You can go either way. And we'll start with the highest setting, the 500 volt setting here. Okay, and we can see a 114, but I want to get a little more detail in my measurement, so I can bring it down to that up to 200 volts, and now I can read it to the tenths. And then if I want, I can press that hold button. It holds the value for me, and then I can write it down, show it to mom and dad, let them know that I have measured the voltage of the light bulb. So if you would like to continue learning more about electrical testing, if you found this fascinating, I have a ton of material on every different meter that you could imagine. I have a bunch of shorts explaining a bunch of different electrical concepts. I urge you all to please go check it out. I hope that you got something out of this, and I'll catch you on the next one.